All right, welcome to the graphics programming virtual meetup. Today we will talking about this article, surface versus volume formatting tools by this person, Claire, that I didn't know who they are before, but I just add this blog to my RSS feed. Seems really nice. Oh, this is a large topic. There will be a second part next week. Do they have a second part? No, typical.
Supposed to do.
Yeah, I also often do that. I write a blog post and said, I will write a second one, but I just didn't. Okay, key takeaways. Triangle has superior math properties for rendering efficiency. Yes, that's why we use triangles. Volume's a better source of truth and easier to sample. Also, yes. Also, yeah, volume have a surface, so volume can be converted to a surface, but not surface has a valid volume. GPU now, yeah, GPU advanced now make us enable us directly work with volumetric data. Future 3D modeling likely shifts to volume first tools. I I don't know. I just don't know anything about this too much, so I don't know. But yeah, triangle remain will be in the final rendering. Hybrid approaches, yeah, there will be hybrid approaches. Fundamental surface versus volume representations. So just cube and spheres with like surface areas and volumes. And yeah, a cube can easily be defined with 12 triangles. For a sphere, it's impossible to define as a triangles without some kind of data loss. I don't understand this sentence.
Because volume scales.
What worst case volume scales in cubic
That part
in
makes sense, I guess, because it's if you're storing it explicitly, that's kind of the worst case, because you have to store, n cubed kind of number of voxels. The other part,
yeah, yeah, that's right. Yeah, yeah. If you use voxels, then also you can't like perfectly represent a sphere without some kind of implicit representation baked in. Okay, so spectrum of 3D data formats. the space of surfaces is dominated by triangles, but there are also other formats. Brief overview of most of formats that come to mind. Triangles, yes. Circles, yeah. Splats, which get popular nowadays. Height maps. Point, oh, point cloud, they treat it as a surface rather than volumes.
Yeah, that's counterintuitive from my understanding of point clouds.
Mm.
But I think it's referring to like if you use like a laser thingy to measure a space, you'd get a point cloud, but that would be a definition of a surface, not a volume.
Yeah.
But if it's like,
Yeah,
you
because
know,
of surface
yeah, no,
area.
guess it really de depends on how you th what defines the point cloud here, or what where the points came from.
NURBS. I'm not really familiar with this. From at least from my understanding, this is basically like a Bezier curve, but in 3D. Is this correct?
That's my understanding. Yeah, they have some control points the same way that that splines do. Yeah.
More like control surfaces, control triangles, control quads,
Yeah.
but same idea.
To the signed distance functions, yeah, SDFs. Other exotic surface, yeah. And for volumes, we have occupancy voxels. That's this Minecraft style voxels. And yeah, density grid. Sparse voxel oak trees. That's a like often heard about this term, but that's something I actually don't know what the data structure is that. And oak trees, OpenVDB had, yeah, I don't know what that is.
OpenVDB is like a hierarchical volume format. It's like a tree structure, but then it can also at certain levels it stores explicit voxels.
Okay. Yeah, from what I heard about sparse voxel oak trees, it's only useful for rendering, not that good for other purpose, but also for rendering, it may not be the most efficient format, so I just don't bother to learn what that is. So for implicit, we have constructive solid geometry. BSP trees. I don't know what this acronym stand for.
Binary space partition?
Yeah.
Oh, okay.
But that I didn't think it was implicit. Huh. So I'm familiar with BSPs from Quake and Doom, like the original ones.
Yeah. SDFs. It's interesting they put SDF both in surface and volume, but I guess, yeah, it's correct. Just how you interpret this SDF.
Mm.
Level sets.
Yeah, level sets are kind of they're it's like sign distance fields, but it doesn't have that Lipschitz continuity thing where the distance has to be valid. It's
Yeah.
basically looking at like the um, Yeah, well, level set kind of refers to like it's a constant value. You can trace out like where the boundary of that value is in the.
Yeah, I just remember this term from calculus class, but I actually never seen it in a graphics context.
Yeah, same. Yeah.
Adaptive distant fields. I don't know what that is either.
Yeah, I'm not sure.
Implicit functions. Yeah. Implicit functions are just like, yeah, just like sphere is uh, center and radius, this kind of thing. Ring of triangles. And triangle is mathematically superior because given any 3 points, you have a Wally triangle, yes. Barycentric coordinates for interpolation is easy and fast and supported by the hardware. Given a fixed 2D perspective, it's easy to sort and organize.
Is it?
Yeah, I feel like you can sort it with Centroid, but it's not really robust.
Okay, I guess I'm just used to the depth buffer solving the depth problem, but sorting triangles from back to front doesn't necessarily strike me as an actually easy thing to do.
Yeah,
But
So maybe with the qualification that given a fixed 2D perspective, that's
yeah,
then the Z buffer is kind of a sort of yeah, interesting statement.
line to triangle intersection is fast. But this is like intersection for a lot of surface are fast though. So
yeah, that's
it is,
qualitative. That's not really a function of the mathematics behind it.
yeah.
Okay, they do explain a little bit, I guess, in the next little bit here. First two are strong arguments, which always hold. The third point is only relevant when moving data from 3D to a frame buffer. So, like we were saying with the Z buffer, yeah.
Yeah. But I guess for debuffer, we just don't bother to sort. The debuffer works with everything, basically. I think they're more talking about maybe transparent and in cases when we do want to sort, then yeah. And last one, I guess, yeah, triangle is not the only one intersection is fast, but there are definitely formats which intersection is not fast.
Mhm.
Yeah, like how do you intersect with any of those implicit format? I guess for some implicit function you can do, but I guess I just ignore what I just said. You can still intersect with those. Data compression factor. Analysis of certain edge will be strongly aware of triangle limits. Do they mean like nowadays artists just use triangles arbitrarily?
Oh yeah, they just want to subdivide a whole bunch. It's funny now. The kind of like artists will ask for triangle limits now, but it's more shading related
Yeah.
these days. It's really costly.
They believe that triangles will remain a dominant format. Yes. Yeah, with retracing doesn't really change things for triangles though. You can do retracing for triangles, and that's what people are not doing. And volume advantage of volumes. And false equivalence. For any volume, there exists a Wallet surface. Yeah, but not every surface represents a Wallet volume. I think there is a mathematical property for that, but I just don't remember the name.
Manifold.
Yeah, that's the term I think about, but I don't really remember what manifold is, so I'm not sure.
Oops, the surface.
Watertight, yes. Method of generating volumes from surface is very mature and well understood. Oh yeah, and so watertight. It's a like informal term, but yeah, widely used. The algorithms are also very expensive for high quality volumes. Conversion from of volumes to surfaces. Marching cubes were locked behind a patent? Really?
I didn't realize.
I,
That
that's
sucks.
interesting.
Like just the more I read about software patent, the less I like it. Just those things sucks.
Get no argument from you on that one. That's definitely agree with you there.
And yeah, it's no longer patented. Good, and also more superior methods like dual contouring, but also harder to understand. I don't know. Complexity spectrum from explicit to implicit representations. So yeah, explicit like triangles and dense voxel grid. And when mapping of data, bottleneck of modern hardware is typically related to I/O. Yeah, and at least memory. If we just do in-memory conversion, it's just Yeah, just a hierarchy of things. Like CPU is fast, memory is slow, and disk just is so slow. And the internet is at the even bottom. Complex explicit representations, texture and UV mapping. Yeah, it's still explicit. Implicit representations are NURBS and SDFs. And NURBS, oh, NURBS is like a subtype of B splines. I think B splines are like Bezier curve in 3D, but NURBS are a particular type, but I just don't remember anymore. And
Yeah, I'm not really up on the classification there.
Yeah.
What that all means.
car manufacturers and people looking for precision surfaces really like these models. Okay, they are computationally expensive. Yeah, BSP trees and CSG. Yeah, but SDF is still also widely used in games though. Building BSP from CSG, yeah. CSG combines simple shapes to complex shapes, while BSP subdivides space for rendering and collision detection. In Quake, CSG was used to design levels, and BSP trees generate from these designs enable real-time rendering. Sparse voxel grid. Yeah, CSG certainly does not work well for artists. OpenVDP is sparse voxel grid, storing only the relevant non-empty voxels in a hierarchical data structure. Yeah. Oh, adaptive grid just means they are not uniform like an aux tree. Yeah, make it possible to handle much higher resolution than traditional dense grid. You can adaptively sample the grid for the desired LOD, and here this maps to certain GPU texture optimization modes. Beyond binary, occupancy and density in 3D representation. Yeah, we can add L occupancy for voxels. Density and material properties. Yeah, we can add additional information for the materials. Also, by the way, if you're using something like dual contour, then if you use just an occupancy as a number for each voxels, then you still need some way to describe how this will actually turn into a surface. So I guess that's also material property. I think I read. I guess I will find that article later. Performance and practicality. Cache compromise. Balancing speed and memory. Caching strategies become crucial for maintaining performance. Both volume to surface and surface to volume conversion can benefit from caching. Yeah, cache data may cause I/O or memory bottlenecks. Cache data often need reconstruction, which can also be expensive. Also, consume a lot of RAM. Surface regeneration. Yeah, one of the key challenges when working with volumetric data is to need to regenerate surface. Can be intensive. As a fast pass surface generation for responsive sculpturing, and then the more correct slow pass. Yeah, most time the user is idle. Yeah, another is for like just directly render the volume using techniques like what Teardom is doing. CPU-centric workflow. Recent advancement of GPU has opened up new possibilities. Direct memory access on GPUs. Oh, modern GPUs can load memory directly from the hard drive. I don't know about that.
Yeah, that's very new stuff. They're talking about being able to move have SSDs on the PCI bus and be able to just do stuff directly across the bus rather than between two devices on the PCI bus without having to go through the
That's
system RAM.
nice. Yeah, keep calculation in VRAM. Yeah, just do a compute shader or something. GPU-based volumetric operations. Yeah, working entirely on GPU comes its own challenges. Yeah, also GPU's memory complexity because yeah, GPU code, GPU and CPU GPU synchronization. Just if we ever need to read the data on the CPU side, then there's data coherence issue. Yeah, which will actually happen unless we only do rendering. Then it's likely we need to read the data on the CPU side. Emerging solutions and future directions. Lightweight volumetric formats. Implicit SDFs and CSG. And yeah, we can often combine SDFs with CSG.
Yeah, the SDFs are kind of a superset there
Yeah.
because you can definitely do it CSG.
Hybrid method. Yeah, I just maybe I just don't know what they will look like. At least from artist's perspective, you need to like work with one or another. You can maybe convert them, but I, I don't know what kind of thing they consider hybrid.
Well, I don't know if you remember the Magica CSG thing. The way that works is they do use SDFs, but they cast or they cache the distances to like a voxel grid. I think
Yeah,
maybe like the closest primitive also.
yeah, I know. Just they were talking about combining surfaces and volumetric,
Hmm.
so I don't know what it means, but yeah, whatever. Conclusion. Yeah, it's always trade-off, basically. And yeah, triangles are still dominant format, but volumetric approaches also offer certain advantages. Yeah, volumes are fundamentally a better source of truth than surfaces. Yes.
Better source of truth is an interesting way to put it, but I get what they're referring to. That's interesting.
Yeah, just a lot of surfaces are degenerated, and for volume, it's can always convert to a surface.
I mean, the prevalence of sculpting in the workflow of 3D models seems like a good indication of where things are going because what can make a sculpt really easily is not going to be the same thing as what makes 3D models easy to render, but they do have a surface that defines the sculpting and tools to modify the surface. And maybe it'd be easier to define it as a volume rather than as a surface to do all the stuff that is needed. But
Yeah, but also nowadays, if artist does not care about triangle count anymore, they just subdivide and subdivide. Then at the end, it's still the engineer's job to make those things easier to render. So
I mean,
yeah,
look
at
at
the end,
Nanite.
yeah. So I think yeah, maybe we will see more sculpting software get used rather than traditional mesh-based like 3D modeling software.
Of note, apparently, I was just looking. This person until very recently worked at Substance 3D. Is it the sculpting thing?
Well, Substance Painter is really awesome because it's
Substance.
texture painting on a model, not on a 2D image, which is painful and annoying.
Let's stop recording.
Oh, also worked on